next is about the refraction. So far we discussed about the reflection phenomenon. Now we are going to discuss about the refraction phenomenon. In this refraction phenomenon, first we will study what is meant by refraction and the applications of refraction. I told you that because of refraction, what kind of things we are noticing around us. Suppose we are standing inside the water. I told you that your legs appear to be shortened when you are inside the water, or if you are noticing a person inside the water, and if you look at their legs appear to be shortened. This is because of which phenomenon? Refraction phenomenon. When you are observing the stars during night session, the stars will be twinkling. The twinkling of stars is because of atmospheric refraction. Why does the stars twinkle? Means the answer for the question twinkling of stars is due to which phenomenon? Means the answer is atmospheric refraction. When you take a glass of water, if you take, this is a glass made up of glass, and in this glass you poured some water, and you have placed a pencil or a pen like this or something you have kept like this, a stick is kept inside the water. If you observe it carefully, you feel that the pencil or the stick appears to be bent or broken. So when you are keeping a pen or pencil inside the water, then you feel that it was broken at this interface of water and air medium. This is because of atmospheric refraction. So the duration of the day will increase because of the atmospheric refraction. So by how much time the duration of the day will increases by? Means at around 4 minutes time, the duration of the day is increased because of atmospheric refraction. Why it increases, I will tell you in the next coming classes. So that means you can see the sun before the actual sunrise, and you can see the sun even after the sunset. How it is possible, we will discuss it afterwards. Okay. So the duration of the day increases by about 4 minutes because of atmospheric refraction. So or else if you keep a 5 rupee coin inside this water or anything, if you place an object inside this water and you look at that object from top surface, you feel that the object is a little bit closer to us. Or if you look at the fish inside the aquarium, from the top surface, if you look at the fish inside the aquarium, it appears to be closer for us. Or for the fish, we ourselves will be appearing farther for the fish. That means when you are looking the fish, fish appears closer to us. When fish is looking at us, for fish, we are appearing to be farther. All these things, if you want to know the answer for all these questions, we have to understand what is meant by refraction. Okay. So what is meant by refraction? If you understand, then you will get the answer for all these questions. Why a coin placed inside the water appears to be raised, or why a fish inside the aquarium appear closer to us, or why a stick kept inside the water appears to be bent, or why your legs appear to be shortened. If you want to know answers for all these things, you have to understand the refraction phenomenon. So we are observing the objects inside the water. That is because of what? Refraction phenomenon only. If refraction does not happen, then what happens? We can't see the objects inside the water. Okay. So we can see when you are standing by the side of a calm surface of water, I told you that we are able to see our image. Along with that, we are able to see the objects inside the water. This is one is because of reflection. That is, you are seeing your image, means that is because of the reflection phenomenon. When you are seeing the objects inside the water, means that is because of refraction phenomenon. Okay. So the image will be formed either by the reflected rays or by the refracted rays. So reflected rays are going to form the image, even the refracted rays will also form the image. So the points where the reflected rays will meet or appear to meet will give the image formed by the reflected rays. In the similar way, the point where the refracted rays will meet or they appear to meet will give the image. So one image is because of reflection, the other image is because of refraction phenomenon. Is it clear? So now what is meant by refraction then? Refraction means, suppose when a light ray is traveling from one optical medium to the another optical medium, what is going to happen is the question here. Let me choose, this is an interface. I told you what is meant by interface in the previous class. An interface is nothing but a plane which is separating two optical media. A plane which separates the two optical media is said to be an interface. Let me choose, this is optical medium 1 and this is optical medium 2. Every time I won't write optical medium, simply I will use the word medium. Here in this chapter, medium refers to the optical medium. What is an optical medium? A medium through which light can propagate is said to be an optical medium. And a medium through which light cannot propagate is said to be an opaque medium. And a medium through which light will propagate partially is called as a translucent medium. So here we are choosing the optical media. There are two optical mediums, 1 and 2. Now let me choose, this is air medium and this is water medium. So out of air and water, we know that air is rarer and water is denser medium. So here if you observe, this is an interface, I told you, this is called what? Interface, which is a plane that separates the two optical media. And now for this interface, I am going to draw a line like this. And this line, if you see, this is a line which is normal to the interface. The line which is normal to the interface is said to be what? Normal line, indicated with letter N, normal line. Now let me choose a light ray is incident on the interface of two media. This is the incident light ray. This is the light ray which is incident on the interface of two media at some angle of incidence I. This is incident ray, incident light ray, or simply incident ray. Let me take it as PQ. PQ is the incident ray. Now if this is a refracting medium, then light ray, while it is moving from one optical medium to another optical medium, will it follow the same path is the question. Will it follow the same path is the question. To check that one, what we need to do is, so let me choose, this is one optical medium and this is another optical medium. You are incidenting a laser beam which is passing from air medium to the water medium. A careful observation says that the laser beam is changing its direction while it is traveling from one optical medium to the another optical medium. And a careful observation says that this light ray will be bent towards the normal line. Like this it is bent. Suppose the water medium is absent. This light ray would have traveled straight without any deviation. Like this. But here, this is a ray which is entered into the second medium. It is traveling from medium 1 to medium 2, that is from air medium to the water medium. While it is traveling from air medium to the water medium, you will notice that the light ray is changing its direction. Instead of going like this, it has gone like this. That means it is bent away from its original direction. So that means it has changed its direction. So what happened here? When a light ray is traveling from one optical medium to another optical medium, it has changed its direction. This you can see it experimentally with a small experimental setups. You can take a light source and you can pass the light ray from air medium to glass medium or water to air medium, whatever it may be. When you are observing that particular color, you will be observing that the directional changes can be noticed. And more clear observation says that when it is traveling from, air is a rarer medium, when it is traveling from rarer medium to the denser medium, when it is traveling from rarer medium to denser medium, the light ray has deviated towards the normal. In converse, that means if it travels from denser medium to the rarer medium, it will bend away from the normal. But in both the cases, what you notice? You notice that there is a change in the direction of light ray. There is a change in the direction of light ray. When does this change in direction of light ray happen? When it is traveling from one optical medium to another optical medium. So what happened? There is a change in the direction of velocity. There is a change in the direction of velocity, I can say. Or else I can say that the optical phenomenon, refraction is an optical phenomenon in which when a light ray is traveling from one optical medium to another optical medium, it will change its direction, or the light ray will bend either towards the normal or away from the normal. So the optical phenomenon in which a light ray will bend while traveling from one optical medium to another optical medium is said to be the refraction phenomenon. Is it clear? And how it is bending, I have shown you here. So let me take here the case where the light ray is traveling from the denser medium to the rarer medium. I have shown you with the case where light is traveling from rarer medium to the denser medium. If it travels from denser medium to the rarer medium, what is going to happen? Let me choose, this is the interface of the two media, and this is the normal line, and this is the incident light ray. So in the absence of the second medium, this light ray would have gone like this, but in reality this light ray is changing its path like this. In this case, this is the angle of incidence, this is incident ray, we told this is incident ray, and this is the ray which is traveling inside this medium. This is named as PQ, which is the incident ray, and this is QR. I will call this QR as refracted ray. This is called as refracted ray. Now, if you see here the refracted ray is bending away from the normal. This is normal. Instead of going like this, it has gone like this. It is bent away from the normal. In this case, instead of going like this, it gone like this. That means it is bent towards the normal. So when does the light ray will bend towards the normal? When does the light ray will bend away from the normal? So here this is the refracted ray. So now when light is traveling from rarer medium to the denser medium, then the refracted ray will bend towards the normal. When light ray travels from denser to the rarer medium, then the refracted ray will bend away from the normal. Is it clear? So now one more thing we have to see here is, this is called angle of incidence. Then what is this is called? I told you in the beginning while we are discussing the reflection. Normal line is very important while you are defining the angles. That means when you are defining the angle of incidence, angle of reflection, now we are going to define the angle of refraction. For all these angles definitions, we require the normal line. What is an angle of incidence? The angle made by the incident ray with the normal is called angle of incidence. Now can you define what is angle of refraction? Or angle of refraction is nothing but the angle between the refracted ray and the normal line. And here also this is the angle of refraction. So the angle between dash and dash is said to be angle of refraction. The angle between the refracted ray and the normal line is said to be the angle of refraction. Is it clear? And now a careful observation says that if this is I, what is this? This is also I, because if there are two lines like this, if this is theta, this must be theta. Now this being I, this must be I. If this is I, what about this? This is I, this is R. So this is nothing but I minus R. Okay. And here if you see, this is I, therefore this must be I. Then what about this? Here if you see, this is R. This is R. And this R is larger than I. Therefore this is R minus I. Now, what is this I minus R? Or what is this R minus I? Actually, if the mediums are not differing, then the light ray should not change its direction. As long as the medium remains same, the light ray does not change its direction. It always follows the same path. So here, therefore, here if you see, this is one medium and this is another medium, and the light ray has changed its direction. So the change its direction means it has bent or deviated from its original path. So what is this is nothing but this is the angle by which the light ray is deviated. Therefore this angle is said to be the angle of deviation delta. So this is what? Angle of deviation delta. Delta refers to angle of deviation. And here this is the deviation angle delta. So the angle between dash and dash is said to be the deviation angle. The angle between the refracted ray and the incident ray direction is said to be the angle of deviation. The angle between refracted ray and incident ray direction is said to be the angle of deviation. Is it clear? So, in this case deviation is equal to I minus R, whereas in this case deviation is equal to R minus I. That depends whether the light is traveling from rarer to denser medium or denser to rarer medium. When light ray travels from rarer medium to the denser medium, angle of incidence is greater than angle of refraction. When light ray travels from denser medium to the, rarer medium to the denser medium, the refracted ray will bend towards the normal, first point. Second point is angle of incidence is greater than angle of refraction. Third point is deviation is equal to I minus R. And here, when light ray travels from denser medium to the rarer medium, the refracted ray will bend away from the normal. Second point is angle of refraction is greater than angle of incidence. And third point is deviation is equal to R minus I. Is it clear? So, these are the things that we have to remember in order to understand the different phenomena that are related with refraction. So, when a light ray is traveling from one optical medium to another optical medium, what is going to happen? It is going to change its direction, or it is going to change its path. The optical phenomenon in which a light ray changes its direction while traveling from one optical medium to another optical medium is said to be the refraction. When the light ray travels from denser medium to the rarer medium, the refracted ray will bend away from the normal. When the light ray traveling from rarer medium to the denser medium, the refracted ray will bend towards the normal. And in this case, deviation delta is equal to I minus R, and in this case, deviation delta is equal to R minus I. Can we see these kind of effects? Means we can see it with simple examples. And here there are laws of refraction there, just like the laws of reflection. Here also we are having two important laws of refraction are there. Before that, let me take this is a white paper which is fixed to a cardboard with the help of pins. Now, on this white paper, you draw two perpendicular lines like this. Now, here you place a glass slab. Here you place a glass slab like this. This is a glass slab. What is this? This is a glass slab. You are placing a glass slab in this way. So, we are taking a cardboard like this. On the cardboard, we are fixing a white paper with the help of pins on four sides. And now, on one side, we are keeping a glass slab. Now, a light ray is made to fall along this direction with the help of a laser beam, a red color laser beam you can use. When it is incident like this, you can measure this angle with the help of a protractor. You are able to measure this angle, take it as some angle of incidence I. Now, if you observe, when the red light is passing through this one, it does not emerge out at this point. Instead of emerging from this point, this is emerging from this point, and it will travel straight like this. Okay. So, what it says? Instead of going like this, it is emerging from this point, means it is coming like this. That means it is bending or not. So, you can see it clearly. We can see with the help of a glass slab and with the help of white paper using a ordinary laser light, we are able to find out this, how the light ray is bending when it is traveling from one optical medium to the another optical medium. Is that clear? So, what is refraction? The optical phenomenon in which a light ray will change its direction when it is traveling from one medium to the another medium is said to be the refraction phenomenon. And due to refraction, the refracted ray, either it may bend towards the normal or it may bend away from the normal. That depends upon from which medium to which medium it is traveling. If it is traveling from rarer medium to the denser medium, the refracted ray will bend towards the normal. When it is traveling from denser medium to the rarer medium, it will bend away from the normal. So, here denser medium and rarer medium I am telling. What is this denser and rarer medium? More clearly, here denser medium in the sense optically denser and rarer medium means optically rarer. General density refers to mass by volume. That density is different from optical density. Okay. Generally, what we studied so far, either in first year or so far in our previous classes or in the previous studies, what we know is density means mass by volume. But here density is not mass by volume. Here density refers to optical density. Optical density is different from the general density. And in most of the cases, denser mediums are optically denser and rarer mediums are optically rarer. Most of the cases I am telling. Most of the cases, why I am telling means, in all the cases it is not true. There is an exception. There is an exception. That's why I can't say that a denser medium is an optically denser medium and a rarer medium is an optically rarer medium. This is a wrong statement. They may ask in the competitive level of examination like CET, they may ask, does a denser medium represents an optically denser medium? Maybe, may not be is the right answer. Okay. For example, I will give you an example for this one. Out of water and the turpentine, if I consider water and turpentine, water is more denser than turpentine. Water is more denser than turpentine in terms of mass density. Which is denser out of water and turpentine? Turpentine. And water, if you choose, the mass density of water is more than turpentine. But optical density is more for turpentine. That means quite opposite case. So, out of water and turpentine, which is more in terms of mass density is more for water. But optical density is more for turpentine. So, that means we can't say that a denser medium must be an optically denser medium. It may be true, may not be true. But most of the cases, denser mediums are optically denser. For example, air and water, if I consider, air is rarer, water is denser. So, it is here air is optically rarer and water is optically denser. Similarly, if I take a glass and water, our common sense says that glass is denser medium and water is rarer medium. Even optical density is more for glass and optical density is less for water. But when I consider the turpentine and water case, very important theory question. Out of turpentine and water, which is denser means water is denser than turpentine, but optical density is more for turpentine than water. I am writing it here. Optical density is more for turpentine than water, H2O. Okay. But water is more denser than turpentine. That means optically denser doesn't say that it is a mass denser, and optically rarer doesn't say that it is in terms of mass density it is less denser, we can't say. Okay. So, that means final conclusion is a denser medium need not be an optically denser medium. Okay. This is about the refraction phenomenon. And now coming to the laws of refraction. What are the laws of refraction we are having? I will discuss now. Regarding the laws of refraction, we are having two important laws. What are those two important laws? First law says that just like in the case of reflection, here also we are having the first law as similar to that of first law of reflection. First law, what the first law says? This is incident ray, this is the normal line, and this is refracted ray. Incident ray, normal line and refracted ray. If you observe it carefully, all these are lying in the plane of the board or not? The incident ray, normal line and refracted ray all are in the plane of the board. That means first law of refraction says that the incident ray, normal line and the refracted ray will lie in the same plane. The incident ray, comma, normal line and refracted ray will lie in the same plane. If incident ray and normal line are in the plane of the board, then refracted ray must be in the plane of the board. If refracted ray and incident ray are in the plane of the board, then normal line must be there in the plane of the board. Is it clear? That is about the first law of refraction. The only difference in the first law of reflection and first law of refraction is, there in the first law of reflection, reflected ray you will take, but in the first law of refraction, instead of reflected ray, we are taking the refracted ray. That is only the difference. Now coming to the second law of refraction, it is very important law, and I can say that this is the Brahmastra for this ray optics. Why I am calling the Brahmastra means, when we are in trouble and we don't know how to solve the problems, or when you don't know how to get an equation in this ray optics, first we have to use the general law of refraction or second law of refraction, and which is more generally called as Snell's law, because it was proposed by Snell. Snell is the name of the scientist. Hence the Snell's law, which is also called as the general law of refraction or the second law of refraction. What does this Snell's law will say? Snell's law or the general law of refraction. Snell's law or the general law of refraction. Very, very important statement, and definitely they will be asking this Snell's law for 1 mark questions or 2 mark questions in the board exams, and without you knowing about this Snell's law, we can't move in this study of ray optics. It's very important statement. What this Snell's law states? Snell's law states that if you consider a pair of optical media, I will write that first now here. And here I talked about the optical density. Then how to represent the optical density? Is there any other name for this optical density? Means, yes, there is another name for optical density called as refractive index. The other name for optical density is what? Refractive index. Refractive index. So the other name for optical density is what? Refractive index, and it is indicated with the letter N. In our NCERT textbooks, we are indicating the refractive index with the letter N. Some other books will indicate the refractive index with the letter mu. So that is your choice. So in most of the textbooks, they will be using the letter mu for refractive index, but in NCERT books, they will be using the refractive index with the letter N. So refractive index is indicated with what letter? N. The other name for refractive index is what? Optical density. Now, I will write the mathematical formula first for understanding the Snell's law. I will write it like this. N is equal to sin I divided by sin R. That is equal to constant, I will write. Now, I think you know how to read this. This is read as what? Sin I. And how to read this? Sin R. And how to read this part? Sin I by sin R. How to read it? The ratio of sin I to the sin R. Yes, sir. What is this I refers to? I refers to angle of incidence. What is this R refers to here? Angle of refraction. Sin I refers to sin of angle of incidence. Sin R refers to sin of angle of refraction. I being angle of incidence, sin I refers to sin of angle of incidence. R being angle of refraction, sin R refers to sin of angle of refraction. Now, I told you previously how to read this one. If A by B is there, you will read it as the ratio of A to B. How to read this A by B? The ratio of A to B. Now, how to read this sin I by sin R? The ratio of sin I to sin R. Or more generally, I can read it like this. The ratio of sin of angle of incidence to the sin of angle of refraction. The ratio of sin of angle of incidence to the sin of angle of refraction is equal to constant. Is equal to what? Constant. But there are some conditions. What are those conditions? What are those conditions? Means the ratio of sin of angle of incidence to the sin of angle of refraction is constant for a given pair of medium and for a given color of light or for a given wavelength of light, because each color is associated with a particular wavelength. That means finally how to state Snell's law means for a given color of light or for a given wavelength of light. It is your choice. For a given color of light and for a given pair of medium, for a given color of light and for a given pair of medium, the ratio of sin of angle of incidence to the sin of angle of refraction is constant, and that constant is named as refractive index. and that constant is named as refractive index. This is nothing but the Snell's law. Understood what is Snell's law? So, Snell's law states that for a given pair of medium, for a given color, and for a given pair of medium, for a given color and for a given pair of medium, the ratio of sine of angle of incidence, sine of angle of incidence to the sine of angle of refraction, is constant, and that constant is equal to what? Refractive index or optical density of that pair of medium. Is that clear? This is called as Snell's law, which is also called as general law of refraction. General law of refraction. And I will call this general law of refraction as the Brahmastra of ray optics, because many of the cases when we are solving the problems, we are going to use the Snell's law. Okay. So now, what is Snell's law statement? Snell's law states that for a given color and for a given pair of medium, the ratio of sine of angle of incidence to the sine of angle of refraction is constant, and that constant is named as the refractive index for that pair of medium. Is that clear? This is the first law of refraction and this is the second law of refraction. Just like in the case of reflection, in refraction also we are having two laws, and these are those two laws. Understood these things clearly? And next we will be considering about the phenomena that are related with the refraction. And before that we will study about some important terms like how to define the absolute refractive index, relative refractive index. These simple terms we will study, and then we will move to the other concepts of this topic. Okay. Now we will be studying about the limitation for the Snell's law. We studied what is meant by Snell's law. Now we will study about the limitation for the Snell's law. So when we are applying the Snell's law, is there any condition? Means yes, there is a condition while we are applying the Snell's law. So what is that condition? Means, as I told you that when a light ray is traveling from one optical medium to another optical medium, it is changing its direction. Suppose the light ray moved like this, what it is going to say? This is the incident ray PQ and this is the refracted ray QR. If you observe here, the refracted ray has deviated towards the normal. That means this medium is which medium? As the refracted ray is bent towards the normal, this is the denser medium and this is the rarer medium. That means sometimes by seeing the ray diagram, we must be in a situation to say which is rarer and which is denser. As it is bending towards the normal while it is traveling from one medium to another medium, this medium is denser medium and this medium will be the rarer medium. Okay. Now here this is angle of incidence I and this is angle of refraction R. And according to Snell's law, what I have written? N is equal to sin I divided by sin R I have written. SR. N is equal to sin I by sin R I have written. If you observe it carefully, this is a constant I told more clearly for a given pair of medium and for a given wavelength of light. This ratio is noticed to be constant. If this ratio is noticed to be constant, what I can say? Sin I is proportional to sin R. What it is saying means as I increases, R also increases. That means with increase in the angle of incidence, the angle of refraction also increasing. Okay. That means what it says, suppose this is the incident ray. If this incident ray is moved like this, this refracted ray will move like this. Okay. This is an incident ray, this is refracted ray. If this comes like this goes like this, because R should increase. If it comes like this, I increases. If it goes like this, R increases. Now, if I decreases, if it goes like this, the refracted ray will come like this. Therefore, if this incident ray is along this normal line, what is the angle of incidence? If this comes in this direction, then I is equal to 0. When I is equal to 0, R is also equal to 0. Why? Because sin I is 0, sin 0 is 0 means sin R is also equal to 0. Finally, what I can say? For normal incidence means how the light ray is incident. The light ray is incident along the normal line. Normal incidence in the sense, light ray is incident along the normal line. For normal incidence, angle of incidence is equal to 0. Please don't think that normal incidence means angle of incidence is equal to 90. That is wrong. So, angle of incidence is always measured with respect to normal. Normal incidence means the light ray is along the normal line. Therefore, angle of incidence is 0. In this case, the refracted ray will go straight like this. This is the transmitted ray. I will say more clearly, R is equal to 0. That means what you noticed here, whenever the angle of incidence is equal to 0 or when the light ray is incident normally, the light ray travels undeviated. That means there is no change in the direction of light ray. If there is no change in the direction of light ray, is there any refraction phenomenon? No, there is no refraction phenomenon. But here there is a transmission. The light ray is transmitted from one medium to another medium. As there is no refraction phenomenon, Snell's law should not be obeyed. Let me check mathematically. I is equal to 0, R is equal to 0. Sin I is sin 0. Sin 0 divided by sin R means sin 0. Sin 0 is how much? 0. Sin 0 is again 0. 0 by 0. Can you define 0 by 0? It cannot be determined. Therefore, Snell's law is not valid. When does Snell's law is not valid? Snell's law is not valid for normal incidence or when angle of incidence is equal to 0. That is the limitation of Snell's law. What is the limitation of Snell's law? Snell's law is not applicable for normal incidence or when the angle of incidence is equal to 0. For angle of incidence is equal to 0 or normal incidence, the light ray does not change its direction while it is traveling from one medium to another medium. It will travel straight without any deviation. Is it clear? So, limitation is what? Snell's law is not applicable. Limitation for Snell's law. Limitation for Snell's law. Very important 2-mark question. Very important 2-mark question. When does the Snell's law is not applicable? Snell's law is not applicable. Snell's law is not applicable. Not applicable for normal incidence. Normal incidence or for angle of incidence is equal to 0. For angle of incidence is equal to 0. For this case, Snell's law is not valid. Is it clear? And though I am writing n is equal to sin I by sin R, in most of the cases while you are solving problems, better you remember the Snell's law like this. As this is a optical medium, it will have a particular refractive index, and this is another optical medium, it will also have a particular refractive index. Let me take the refractive index of this medium is n1 and the refractive index of this medium is n2. Now, the general law of refraction can also be taken like this. Mathematically, I will write it first. n1 into sin I is equal to n2 into sin R. What I can say? n1 into sin I is equal to n2 into sin R. Or I can write it like this. N into sin theta is equal to constant. N1 into sin I is equal to N2 into sin R. N1 into sin I is equal to N2 into sin R. You see, so I will write that as N sin theta is equal to constant. What does it means? It is N sin theta is nothing but what? Product of the two terms. Product of N and sin theta. So the product of N and sin theta is a constant for a given pair of medium and for a given color of light. How to define the Snell's law in more general way means it is defined as the product of, a refractive index of a medium and the sign of angle made by the light ray with normal in that medium. With normal in that medium is always a constant. How to define? It is defined as the product of, refractive index of a medium and Sine of angle made by the light ray, whether it is incident ray or the refracted ray, sine of angle made by the light ray with the normal in that medium. In that medium only we have to take. Okay. Therefore, always better you take n1 sin I is equal to n2 sin r, or refractive index of this medium into this sine angle is equal to refractive index of this medium into this sine angle. That is how we have to remember while you are solving the problems. Better instead of remembering the n is equal to sin I by sin r. Is it clear? So, this is about the limitations of the Snell's law. And next we will study about the what is meant by absolute refractive index or optical density. Absolute refractive index, simply I can take Ri for refractive index, or optical density also we can say absolute refractive index. Means what? So, what this optical density or refractive index is going to say? This is going to say how optically active that medium is for transporting the light radiation through that medium. So, every optical medium will have some character in order to transport the light ray through it. So, whether the speed of light ray while it is traveling from one medium to another medium, the speed is going to be changed, I am telling. Why the speed is going to change means the optical character is going to change. Optical character is based on what parameters means? It is based on the electrical character and magnetic character of that medium. In the case of electromagnetic wave theory, we discussed that the speed of light c is equal to 1 by square root of mu naught into epsilon naught. In any other medium, the speed of light is given by the formula v is equal to square root of mu epsilon. That means what are deciding the speed of a medium? The speed of light in a medium. The speed of light in a medium is decided by the electrical and magnetic character of that medium, and that is related with the optical density or the refractive index here. And this refractive index is defined like this. Refractive index is defined like this. So, what it says? The absolute refractive index is defined as the ratio of dash to dash. The absolute refractive index is defined as the ratio of C to V. What is C? Speed of light in air or vacuum. What is V? Speed of light in given medium. So, here n is equal to speed of light in air or vacuum. Speed of light in air or vacuum divided by speed of light in a given medium. Speed of light in given medium. Now, what it says? Absolute refractive index is defined as the ratio of dash to dash. Absolute refractive index is defined as the ratio of